Good day, I'm Derrick Hogan with North Georgia Technical College. Now, I've got a little interesting situation today. Okay, as you can see, I have some mills. Okay, I have plenty of mills. I have several mills here. I got some horizontal mills, I got some vertical mills. I even got a big beast of a mill back here in the corner that basically, is a really big, beefy machine. Now, I've got my mills covered. I also have a decent amount of lathes. So, I'm not normally in this situation. But what do you do if you don't have a mill and you need to do mill work? Well, what do you do if you don't have a lathe and you need to do lathe work? Well, that's where things could get interesting. Can you do a lathe part on a mill? Can you do a mill part on a lathe? What if I turn everything upside down and we figure out how to make that work? So today, I'm going to do a lathe part on a mill, and we're going to do a mill part on a lathe. Okay, here's my dilemma. I am sitting in a shop and I have a piece to turn. The lathe is not available to me for some reason or another. The part's relatively small in diameter. It has some not very complicated shapes on it. So I don't have a lathe, and I'm not sitting in his shop with multiple tools available to me, so I have to kind of work with what I can find and what I can use. Well, I have at my disposal a milling machine. So how can I use a milling machine to do the turning process? That's what I'm going to go into today in this part of it. Now, I'm also going to show you how to use a lathe for a mill. Now, these are not ideal ways to use these tools, but they are alternate methods you can use if you have to, or if you need some other non-traditional solution to a problem. Okay, when you're using a mill like a lathe, there's a couple things you have to do. One, you have to clamp your piece, your tooling, in the vise, just like you would a traditional workpiece. We're going to clamp our piece in the collet, like we would in a lathe chuck. This is going to allow us to be able to, turn this down like we would on a lathe. Next thing we got to do is we got to find center, just like you'd set center heights on a lathe. So what we're going to do is bring the tool bit over so it's roughly in line. Then we're going to take a roller and we're going to put the roller tip, the tip of the tool on the roller, and use it like we would if we're trying to do a traditional setup here. This will work just like it would on a traditional setup here. You can move over that way a little bit more. Take your eyeball to get it close. Now we bring this in on our x-axis. Bring this in our x-axis, we'll be able to see by how this ruler looks as to which way it's angled. As you can see, when I clamp it, the roller is going to angle back away from the part, which means we're too far towards us here. So we need to move the cutter back a little bit. So what I'll do is move the x-axis back a little bit, move this back just a tiny bit, and repeat the process. We want to get the ruler as straight as possible. This is, like I said, one of the ways you can center a tool on a lathe. It also works on a mill machine. It's still leaning back this way, so we're going to go a little further back. Repeat the process again. Is much closer now, so we're going to, I think we're going to go with that. That's actually pretty close there for us. Okay, so now once we've got this in there, this becomes a matter of being able to do just like we would traditional turning. So what we would do is we would move in and we would touch off on the outside, and we'll be able to use power feed using the quill feed to cut our piece. Now, if I was going to cut an angle on this piece, one thing I'd have to do would be to take my head right here and angle my head the angle I want it to cut. And then I'd have to use the knee to bring it up instead of using the quill to bring it down. So it's a different way of doing the same basic process. And put over here, you want to set this to 6 thousandths per rev right here. So what you can do here is pull this out. Now, it doesn't want to pop in, so you can rotate it down there a little bit and get it to pop in the rest of the way. This can also be done using power in the spindle on. Keep rotating, it should pop in. There we go. Okay. So now your power feed's engaged. So what I would do, since this right here is going to read off the radius right here, I would take, let's just say 20 thousandths off. So let's go back to the 10 thousandths reading there. Okay. That should be good there. Okay. Now take your spindle back on. Make sure your spindle rotation is correct. Okay, that's good. You want to engage your power feed. And the power feed right here is this lever right here. So pull. It's going to feed down. Oh, you fed the wrong way?
Yeah. Now you turn that off. Is that the best way to do it? Just take that off? Yeah.
It's also fed the wrong way. Also, you see how we do 10 thousandths positive, we need 10 thousandths the other direction.
There we go.
It's not feeding down.
Yep.
So you reverse the feed here, but pull the pin out. Just the pin in.
There we go. Should be easy to do it now. You say you have it.
Engage. Okay.
And how far you want me to go up with it?
Half inch. So you're going to use half inch on the through there. So now, what I would do is here is reverse my feed.
Go back.
And feed back the other way.
Let's change this over here. I'll put a little bit better finish.
Yeah.
And you want to bring this down to
So half inch basically. What I would do right now is to zero that back out. Zero, that's zero. Get a micrometer, mic this, and let's see where we're at.
okay.
So now we're taking a measurement here. What do you got on the measurement?
Got 607, so
Okay.
607 thousandths.
107 thousandths, so we got 107 thousandths more to go. Now, since this reads off the radius right here, what does our readout need to say when we're done?
So you got 2.165.
If we're trying to get it down to a half inch,
107 thousandths to go.
so it needs to be 50. It should be like 53
53
and a half. Yeah.
53 half thousandths. Now that would be a total cut. So what I'll probably do is take 2 cuts of 20 and then 1 cut of 13. Get there.
So this way,
Put down a
we
little.
got a little bit that it's going to mill on. This way,
Here's a negative move
it's got,
here.
80 thousandths.
Okay, good. Spindle on. Engage the power feed. Stop. I'll feed the rest by hand. Feed the half inch. Good. Do it again. Dollar with that next one.
You're going to go down, you're going to go on for 750,000. So if I go here to job,
Used to the thing.
That's surprisingly well doing it this way. It's like I said, it's not an ideal way to do it, but it is a alternate method to be able to do some simple turning when you need to do turning and you don't have a laser there with you.
take it out, reverse flip it,
And then obviously be the 13 thousandths here. Yeah, you went a little bit too high. That's the whole tricky thing about doing it using
I'm
power.
trying to like, yeah.
So, you know, this is a situation where this does not necessarily disengage as easy as some other things do.
Yeah.
Now you can do it strictly by hand. If you want to do it strictly by hand, what I probably would do, instead of using my quill feed, I'd use my knee feed here to bring the whole table up and down.
Yeah.
Which is also how I'd have to do it to do a cut an angle piece. So, granted, you know, you just kill it apart, but
Yeah.
if this was something that mattered, you kill it apart. So it's just an experience for you here. So reverse this right here again, let it feed itself back out. That cuts the spring out of it. And what we want to do now is measure the diameter and see how close we are.
I want to go, while I'm here, I want to go and set my tool diameter. So I go set up tool table. It's already got 750 in there because of what she did last week.
That's right.
Don't do this.
It's 51.
Part,
Or
mess
50.
So about 1/1000th off. That's not bad. That's not bad turning for a mill machine, is it? Okay,
and
now
we left it at 750.
once again, like I said, I do have other things I can do with this. Like if I wanted to, I could break these 4 bolts loose right here, and then basically turn around here and index it around. And then my head's going to be at an angle here. So what I could do with my head at an angle is I could use my knee to cut an angle on my piece. So, you know, it's not the simplest way to do turning, but it's an alternate method that will work if you don't have a lathe available to you. Okay, so if you don't have a mill machine, you can square a piece up. So on a lathe. So I got this piece of round stock here. It's being held in a 4-jaw chuck. The 4-jaw chuck is going to allow me to rotate this and clamp using the ends on it. Now, a couple of things here I could use. I have these rings right here, and I can use these rings to get myself roughly aligned. I do not necessarily have to indicate this end because of the fact I'm just basically facing the part off. But getting relatively close is a good thing. Now I need a couple of dimensions. So over here, I did blueprint, it's got its dimensions on it. So we're going to make a inch by 1 5/8 block out of 2-inch diameter stock. So the first cut we're going to make is going to turn this down to 1.812. So we're going to face off of one side the material that's necessary to get us to that dimension. We're very close to touching.
Right there, yeah, there you go.
Now, engage the power feet.
So weird.
It basically is facing that side off. It's kind of a face mill.
Yeah, you can see it getting flatter.
But what you get is doing this using a lathe instead of a builder tool. What we're going to do is we're going to take down, get close to the 3/16 we have to take off, and then go about getting the rest of it. With the center. And if you look, you see how you have the start of a flat surface on the piece here. That start of a flat surface will ultimately become just one side of the piece. Okay, now we've got the piece, one side of the piece face. So what we're going to do is put it this side right here and put it up against one of the solid jaws so that it has the ability to be located by that. And we're going to go about facing another side. On this other side, we're going to face to a different dimension. The dimension on this side right here is going to be 1.5 that we're shooting for right here. And that's going to go about getting us closer to getting our 1-inch dimension on this side right here. Then once we do it, we'll flip it again and do another side. Okay, now that we've done some roughing on this right here, we want to take a rough measurement on it Now you can see you're not going to be able to really get in here and measure in behind this. So what we have to do to actually get a measurement on it is take it out and mic it and see where it's at. And once we get there, we can get an idea about how much more we need to go to get this piece down to size. Put square up against it. As you can see, it actually does a pretty good job of squaring up the ball. Now we got a little bit more we need to take off the surface right here. We should bring that down to where it actually cleans up and have a square corner. So we pull it off. Okay, to give us a place for this face right here to rest on, we're going to run this jaw completely out and turn it around. I'm going to do that on both sides here on this longer dimension here. That's going to give us somewhere for that face to rest on. We're going to do the other side, which should allow it to stay true. So you want to have them roughly centered up, that way they spin truer. So this is going to allow you to have a more balanced operation with it. The same deal on the other ones right there too. You want to keep them roughly centered up.
Yeah.
At the same time, you have to have a way to clamp the piece. So, which way you put it in here, in this case, doesn't really 100% matter. You can go technically either way. Personally, if it's me, I'd put probably the long face down on those jaws that you have right here.
Oh, okay.
Yeah.
Okay.
That allows you to have that area to hold with. Use the rings on the face here as a way to basically get yourself roughly aligned there. A little trick I do a lot of times is I give myself a ring and I'll count the revolution so it touches.
Yeah.
Back up past that revolution. That gets you ballpark. You know, it's not perfect, but it's ballpark. There you go. Once again, because we're facing, we don't have to have that be exactly centered. Now, if I was doing drill work with this right here, I could. Now, I could technically do drill holes in this. You know, I could take and offset my jaws around and drill holes. That would be complicated. You really wish you had a milling machine at that moment in time.
Exactly.
But you could do that.
Yeah. Move this over a little bit.
Never said this was easier than I think so.
Yep.
But it works. That's the nature of stainless.
Yeah.
Stainless is nature, sometimes hard to get chips to break really good wood. As you can see, we've almost got it to size here. It's very much turning into a rectangular piece to a round piece. Now, one thing to notice, we're still a little bit here. This is a sign that we're not quite to size yet. And another little thing that's kind of unfortunate with this is there's not a great way to mic this right here while you're sitting here. So you're going to have to probably take the piece out to really get a good measurement on it, get an idea where it's at, and then put it back in there. So that is the advantage about having it resting on those jaws right there. By resting on those jaws, it allows you to have a reference point you can go back up against. Okay, and as my part finishes up here, now I still have a little bit more to take off on this right here, but you'll begin to see I have a square block. I have a rectangular shape, it's not a square, but it's a rectangular shaped block. I can continue to take this down to size. As a matter of fact, it's a pretty good looking and pretty accurate block. This is not an ideal method to go about machining a piece, squaring it up. But once again, if you don't have a mill, what do? You get creative on what you have. I've always asked my students in class, like, how do you think they made the first lathe without a lathe? Or how do you think they made the first milling machine without a milling machine? You know, there's ways to do this stuff, but it's not exactly the easiest in the world to do. In this case right here, this is just a way to square a block up. Not ideal. I'd use a mill every day, all day beforehand. So, but if I don't have a mill or my mill is down and I need to do some mill work, it's another way. Now, as crazy as it is, I could do additional mill type work on this right here. If I wanted to, I could offset these jaws around different amounts and drill holes in locations. It would not be efficient, but it would work. So I could drill a series of holes in this. I could drill a whole pattern of this right here. I'm not going to do that because I'm not really into torturing myself here. But, you know, once again, it's a way to work. It's kind of like the whole thing with the lathe, with the mill with the lathe. The lathe with the mill, that is. Basically, golly, it's so confusing because I'm talking lathe and mill all at the same time. But when you're running, doing a lathe part on a mill machine, it's not ideal either. But it can be done if necessary. Okay, my name is Derrick Hogan. I am with North Georgia Technical College doing some work videos here for Practical Machinists. If you have any questions, feel free to toss about in the comments, and be sure to like and subscribe, and let me know if there's anything else you want to see. Thanks. So I just thought I was done. I decided to add something to this one. I was thinking about it and realized basically there's another way to do it on the lathe, on the mill, using the mill like a lathe. I wanted to show you all. It involves an offset boring head. Now, normally for cutting traditional bores, I'm gonna have my boring bar in there like this right here, kind of facing away from it. What I can do is put my boring bar in there the opposite direction. Now my boring bar, while I get this in position, my boring bar is facing back towards the inside of the cut. So when I go to make my cut, now I can turn off the outside of my piece. This is another way to do a turning operation on a mill machine. Okay, so what we're going to do now is we're going to edge find this. And to edge find this right here, we're going to turn our spindle on about 1,000 RPMs or so. And you can see right now that we're actually up around 3,000 RPMs. I am in low range, so I turn this on to be fine. But what I want to do here before I actually flip it over to high is run this down closer to the speed I want it to be. If I turn this on right now, my indicator tip, my edge finder tip, is probably going to go through a window over there at about 100 miles an hour. So let's go ahead and let's turn the speed on and low and back this down. Okay, so what we're going to do is going to move over here and touch off on the one side. Zero out and readout. Raise the spindle up. Move across. And when we get to the other side here, we're going to drop our spindle back down. Move back across. We touch off again. Right here. Now we got a number of 1.6378. I could divide that by 2 and get my center line, but a lot of readouts have a button for this. This one has a midpoint button. You can mouse the midpoint button on it, and then mouse the opposite you want to. It basically finds the center line for you. So now the center of my part is my 0 location. So that's going to allow me to work off of this. We're going to repeat the process on the y-axis. Okay, so we got our piece mounted in the offset boring head right here. I could go a tiny bit further with this right here. That's probably pretty close as far as I'd go with this. But you can see the limitation with this right here is going to be a little bit of the diameter. Now what I would want to do here is bring this over till it touches. So what I would do to do that is adjust my dial in there until it touches on the corner. Then lock the locks out and then start making my cuts. And overall we can begin to take this down to a controlled diameter.
There you go.
Okay, so touch on the corner.
Like a little chip out.
So that can be our kind of 0 point right there. So we raise this up, and then basically let's dial it over about to the 0 on this right here, and then make our first cut.
Alright. Just like so.
Okay, now let's turn our spindle on. And actually, your power feed's engaged here. You got our feed rate set here. We're good there. Turn our spindle on. Now pay attention to how it rotates. Let's turn it off for a second. Look at your insert here. How's your insert? It's rotating backwards.
Yep.
So this may be a situation where it's backwards from what it would normally be on the machine.
Alright.
So what I do is flip it around the other way. Okay, now engage your power feed right here. See that? Good. It's easy to discover sometimes. We got apparently a machine the power feed stopped working on. So that's okay. So what we're going to do is we're going to do this by hand. We're going to bring it down close. So close to touching the corners. Lock it out here, and then we're going to feed up using our knee. That'll allow us to make a cut. As you can see, it's just taking a very, very small amount off the corner here. So we're going to dial over probably about another full revolution on the second cut here. You go about maybe 4 turns. That should be good. Now, just go there, zero out where you're at.
Alright.
That should be a stop point. See that's it? Almost at 0. Now raise it back up. Turn the spindle off and dial over a full revolution. So we're going to do another full, that'd be like 50 thousandths off the diameter here. It should not be a problem to cut, consider this is aluminum.
Just want to see if it's going the right way. No, I did not.
See it the wrong way?
Yep.
Ah, a little learning moment.
Clockwise.
Once again, that will be backwards from what you normally would do in an offset boring head.
Alright, just about.
Spindle back on. Okay. Dial it over again.
Alright.
And we're going to keep repeating the process until we get closer to a full diameter, and we'll do some measurements on it and go from there. So there you go, we got a full diameter here. Now, we can continue this process on and measure and determine what size it is and adjust to get it to the actual size we're looking for. But this right here basically shows that once again we're using a milling machine to do a turning process using an offset boring head to do so. You can also see how it did clean up all the way around, so our centering on this stuff here was good also.